Hold on 1 second. Let me get my mug up here. There we go. Greetings and welcome to Backyard Physics. I'm Professor Bob Riggs. This is I'm coming to you straight from the bowels of Flersham Hall. Well, actually, the first floor of Flersham Hall in my little windowless office. This is our Howard Stern physics way of teaching a class. Anyway, I sit here by myself and talk to students that are out there in the netherworld. I think you're going to enjoy this class. The input that I've received from students is that it's pretty good. You know, there's some constraints because we don't meet as a lab, but I am going to implement some new things, one new thing for this semester that might help cut down on the email. Well, won't maybe cut down on the emails that I get, but it'll make it more of a you'll feel like you're not out there alone because I'm going to include a discussion board um, for you to utilize. I hate that word, to use. Okay, as the course goes on. But anyway, let me introduce myself. I'm starting. I'm wrapping up my 10th year here at UMKC, and I came here in '06 after spending 10 years in alternative high schools in the Kansas City area, teaching math mainly. My PhD is not in physics. I am a math and science educator. That's what my PhD is in. It's on the curriculum and instruction side in math and science education. I know a lot about physics, and being 10 years hobnobbing with my colleagues, I know that kind of like when I would hobnob with real mathematicians when I was a math teacher. I consider uh, uh, here'd be an example. Here's an example so that you can get used to seeing. Sometimes I go off on tangents. People say, but I don't think so. All right, but anyway, here's a blank sheet of paper. Say this square represents most of the physics knowledge that is out there. All right. By the time you finish our 2 semester sequence of the calculus, even the calculus based physics, you know this much physics. All right, there it is. There it is. So when students see something on YouTube that's over here, and I probably know this much physics. Okay. So when students ask me about something out here, I have to go look it up myself and find out or talk to a colleague or something. And some of my colleagues probably know like this much. And because we have cosmologists, we've got astronomers, and all kinds of different. But anyway, the physics base is pretty big. But just in science, the reason that I really enjoy this class is I get most of you are afraid of science or afraid of math because you've had horrible experiences with it at some point in your life, and I apologize for that. You never had me. That's no. Um, but I think our science education in this country is being woefully inadequate because it's either taught badly or it's been ignored. I mean, we've got we're coming. I'm starting to see my students, and not any of your fault. Um, Coming off 10 to 12 years of schooling with no child left behind. And we were so much into drill and practice on language arts, reading, and math, arcane BS math, that science got pushed to the background. And that's very dangerous in these times. Because to have a good understanding of what science is and what it does, and I think is very important. And so throughout the semester, I'll probably make little not digs or slights at people who aren't that highly educated in science. That doesn't get us that doesn't promote the dialogue, and that doesn't do anything to help us understand one another, or understand what science is. But I will make comments on that. It is important that we understand what science is. Here's a classic example. Um, I, I'll just touch on climate change real fast right here. The science is in. Climate change is real. The issue is, how do we pay for cleaning it up, and who's and are we too late? Those are the big issues. I mean, it is a real thing. Science is a real thing. Okay, there's not a belief in, well, I don't believe in climate change. That's like saying, it's not the Easter Bunny. Science is not the Easter Bunny. When people say, I don't, I don't believe in evolution or something because of a religious reason, that's where we have a real misconnect. Science is not a belief system. Science is an academic endeavor that tries to explain how the universe works, all right, with logic and mathematics, using logic and mathematics. And the main thing is, and what we're going to be doing in this class, is through experiment, okay? Like, let's take a ridiculous, I've used two that are kind of controversial, but let's take one that's ridiculous. I don't believe in gravity. Well, I don't believe in gravity either. There's no belief in gravity. Gravity is not Santa Claus. Gravity is not gravity, and I'm a good Presbyterian. And gravity is not a god. All right. The way nature works, the way by experiment, we've done experiments with gravity over. Every time I drop this frickin' pen, okay, it hits the table. All right. Wow, something is pulling that down. And we ask how, not why. We ask, how does that work? And by experiment after experiment after experiment, I know that gravity is real. And until somebody else comes up with a better model and through experiments can show that it doesn't always work, then I'm going to say gravity is a real physical thing, and this is how it works. That's the way you do science. There's no belief in it. All right? There's no belief in it. There is experiment that shows after experiment after experiment, it adds to the theory until it becomes a known fact. All right? And so that's, sorry, I got off on my soapbox, but for us to not understand that that's what science is, and that and I think that what people want sometimes. Oh, here's a classic example. A classic, and I'll probably shut this off and show you when we come back what I mean, was the ice storm that did not happen, which was great for me because we were touring the West Coast. We were in Seattle and Davis, California, where my stepdaughter lives with her family, and then we went up to Seattle to see my father-in-law and sister-in-law who live up in the Seattle area, because he's moved into a place, he's can't live by himself anymore or anything like that. He's 92 and he's doing pretty darn good. I know my wife and sister are kind of sad about his decline over the past year, but I mean, for 91, he's gosh dang it, he's hanging in there pretty good. That's irrelevant. Was the ice storm, and people getting mad at the weathermen. Why are you predicting such gloom and doom? And you're just trying to sell ratings. They really aren't. They really, sometimes they do. When they used to come on, I mean, you all missed most of it. Some of you are probably too young to remember the Katie Horner days, and I felt sorry for her because it wasn't her choice to go on there when there was a line of thunderstorms coming and being on air all the time. I think with the fragmentation of television, they've kind of stopped that practice because people just go, I'm going to cable, But anyway, and people, well, how did you get it so wrong? Well, they didn't get it wrong. They didn't get it wrong. I mean, the ice storm was actually deadly south. If one little data point is, I mean, they're making a prediction based on if these parameters hold, here is a good chance of what could happen. If these parameters don't hold, then we've got to make another prediction. And eventually you get to the point where you just have to say, okay, we've got all the data we need. Let's make this, it looks like it could be pretty bad. But I was looking at what the projected temperatures were just on my phone and going, I don't know, it looks like it's going to stay kind of warm enough so that it's not horrible. Could get horrible at night when it freezes over or something like that. So anyway, that's why we study sciences, so that we get an understanding of how nature works and how scientists actually work. You know, it's not a belief; it's a um, it's a real thing that you study. It's like this calculator. You know, it's there. I can touch it and I can make um, observations of it. Okay. So I'll get off my soapbox here, but I'll show you the Lorentz butterfly thing, which I think actually Brian Busby does a pretty good job of explaining how difficult, especially when the weather gets colder, um, how difficult it is to predict, because they've done it before. You know, oh, we're going to get 12 inches of snow, and everybody's like, yay! Or I'm going, oh my God, I've got an aircraft carrier to scoop, because we've got one of those raised ranch type houses, so the garage is underneath behind, and so I got to scoop out like 3 lanes of driveway, and then the whole lane that drives up. Oh, it's awful. But anyway. So that's where welcome to Backyard Physics, and this is your quick introduction into who I am, and you can understand and what the framework of why I teach science and why I think it's important. I went to back in I grew up in Liberty for the most part. I grew up in western Kansas until I was 9. And then my dad was worked for Hallmark Cards, and we moved to the corporate headquarters in Kansas City back in the 1969, and I graduated from Liberty High School in 78. Went to Mizzou on a Marine ROTC scholarship. Was off in the Marines for 12 years on active duty. Stayed another 10 years in the reserves. I'm a war veteran of Desert Storm and of Iraqi Freedom. And as a reservist, I don't want to over glorify Iraqi Freedom by any stretch. I was a major on a general staff in Kuwait for the most part. We went. I've actually had some students over from Basra, Iraq, where I wound up for a little while. But mainly, for those of you who are veterans, I was a PowerPoint ranger. They'll know what I mean by that. I was a briefer. I prepared briefs, and that's what I did during Iraqi Freedom. So, you know, I pretty much got 3 squares and lived in air conditioning for quite a bit of that. Whereas some of the people that were out there doing things, you know, much different. Anyway, so that's who I am. And let's go ahead and go to track 2 here. Out here with this part.